Hi, my name is Michael Murad, and I'm from the Music Affect Data Collection team. I'm going to start with a brief introduction that'll describe the application and the team. I'll show off some highlights from our application. I'll discuss the development and finally conclude with the future of the app. So, starting with introductions, we are an eCampus team that has 4 members, which are Tanya, Mia, Chris, and I. We have a project partner, Professor Patrick Donnelly from the Soundbender Lab at OSU, and he commissioned us to build an application. And the idea is he wanted to do some basically field studies where we could crowdsource emotional data response to songs. And the idea would be that a user could play a Spotify song and be able to tap on some UI and sort of share what their emotional response to that song is, and then submit it to a server where we would save it. Later, we can maybe train an AI model to look over that data and create like a playlist that can make someone feel less unhappy and guide them towards being happy based on the data that we collect, for example. So this application can be used by anyone for any song so long as they have a Spotify account and have either an iOS or Android platform. And we were able to do this using Flutter with an AWS backend. So let's speak to some context. Now, there were some existing studies, and these actually proved pretty useful, but they also had their issues as well. One of the things that we gained from them was the idea of the valence arousal model being a sort of universal standard. Another thing that we gained too is not just to sort of have like an overall emotional response for the whole song, but to gather that data over the course of the song. And so to describe the valence arousal model, you'll see it here. We use it in our application. This is actually our UI from the application you're seeing here. Arousal will mean sort of the intensity of the emotion, and valence is essentially, is it positive or is it negative? And so based on where you tap, there's different sort of emotions that correspond. So the top right of it would be excited, top left, that would be anxious, bottom left would be bored, bottom right would be calm, and right in the middle, I guess, is perfect zen. So let's start with some highlights here. So first things first, our mentor really wanted us to be able to capture data about users, like their region, and as much as we sort of could so that we can use that in that data set. And to be able to do that, you have to log in and be able to differentiate users. So we use Firebase to do that. And essentially we use the email password scheme. There are others if you want to do SSO, like use Google or Facebook or Meta or whatever. We chose the email password, and essentially this really simplifies logging in, and it handles the token regeneration and allows you to use it for authorization. Really, really cool. And you can see here, this is the UI that we built around that. And you can create an account, you can forget password, and eventually you will be able to collect all the data that we want about a user and save that and be able to identify it. We have a tutorial. So to use the app, it would be nice to know how it works. And we do have a tutorial on the tab bar on the right. You click on the little question mark, it'll take you to this tab, and it'll describe the process, what to expect, and essentially describe the grid and what you need to do as you record your data. And speaking of recording data, this is what it looks like. These are all screenshots from the app. So essentially what happens is once you connect to Spotify, you push play and it starts a song. And you can see here, it'll give you some information about the song, have a little progress indicator. And throughout the song, you can tap on this grid here. And essentially it captures those Cartesian coordinates, and whatever your last tap was, or just the 0, 0 if you haven't tapped, it'll capture that data on a 1-second interval until the song ends. And then upon conclusion of the song, you can choose to send that data to the server and it'll be stored. And you can see on the bottom there, it also shows you your last coordinates tapped, so you can kind of remember where you last tapped. So speaking to development, early on we had a research stage, and essentially it's where, like I mentioned, with those data sets where we found similar studies, that's where we discovered the valence arousal model and to record data over time. And then we also decided on tools. We found that Spotify was the best sort of song platform. The school gave us an AWS account, so that made that pretty easy. And we used Flutter to build the application. And so we started planning out. We decided that we were going to use an API gateway, which is an AWS tool that acts as a buffer between like the world and Lambda functions, which we would use, and then our Postgres database. And then also we sort of planned out what the page, like the apps and the pages in the app would look like on the right. created an algorithm on the left, which is very close to what actually was created. And on the right, you can see we had a plan of how we would interact with the gateway and our Lambda functions, which are running Node.js, and then our SQL database. So initially, as you can see here, we spent a lot of time just creating what we called the tapper, which was the UI grid that would collect that data, normalize it to be between -1 and +1 for the X and Y coordinates, and get that set up. Meanwhile, we also set up the backend with those Lambda functions and the database schema. So Tanya and I were tasked with the front end, and then Mia and Chris were the backend team, but there was obviously some crossover. The middle stages here were probably the most difficult, and this was actually integrating SDK, the Spotify SDK, into the app, getting it to play songs, being able to record data, and then being able to submit that data to the database, have it be saved, and also be able to retrieve this data. This is the meat and the potatoes of the application, and quite a bit of effort was put into doing this. Then lastly, there was sort of like the refinement stage, what we're currently in, refining that tapper model, removing those colors to possibly remove bias, adding the tutorial page, having the automatic end of song detection added to when you record data, adding the login, and of course adding those OSU colors. I think that's a beaver orange, you can see there. Deviations. So essentially we expected to build a web application. I think, and we still can, the Flutter framework can do that, and I think a lot of the code can be used to do that. However, it's quickly became clear that it was beyond the scope of what we were sort of capable of doing with the time allotted. And I think we had a lot of like far-fetched ideas about Spotify functionality that we quickly came down to earth on, because Spotify SDK was not only difficult to get working, but it's even difficult once it was working. So, there was a lot of challenges. It's designed for native apps. We're using Flutter, so that wasn't one-to-one. We found a wrapper in Dart, but it was really tricky. And then moreover, Spotify behaves differently, whether you're on iOS or Android, or whether you're using a premium or free account. And all the permutations that you can get with those can create a really challenging environment for trying to have a sort of consistent behavior. Very challenging. But we seem to solve most of the problems. It was a lot of work that was done there to do that. Also, we had to learn a lot of new tools. So there's a lot of research that had to go into learning Flutter, AWS. We use Node.js for our Lambda functions, and Prisma is an ORM that we used for Node.js that made it really simplified to like talk to our database. And so that was difficult as well. And also, our app is the first of its kind, so there wasn't like a lot of other applications that we can kind of copy the sort of build. We had to kind of envision a lot of these things ourselves, and we're not designers. Kind of tricky. So for conclusion and future development, essentially we're going to keep working until we can't anymore, until code freeze, continuing to, make changes to the UI based on our sponsors' feedback. Professor Donnelly certainly has an eye for design, and he helps us, make the app a lot less hideous. We're going to continue to fix bugs. One thing that Professor Donnelly would like for us to do is to sort of Dockerize our backend so we can just hand it off to him. And in that, we would also have to transfer all these resources over to Professor Donnelly and Soundbender. And that would be the future of the app. And hopefully it will actually be used. That would be the coolest thing of all. So with that said, speaking from the team, we had a lot of fun building this. It was a lot of hard work. And thank you so much for watching this presentation.